Hello everyone. Today my group and I are going to present our research project titled Predictive Restaurant Ratings with a machine learning approach to uncover customer satisfaction drivers. To begin, this research seeks to ask the following question. Can we predict how a customer will rate a restaurant before they even write their review? And if so, what factors drive that rating the most? For that purpose, we used a real-world dataset of customer restaurant evaluations collected across 3 Mexican states: Morelos, San Luis Potosí, and Tamaulipas. It includes over 1,100 observations capturing vital information about restaurants' attributes and customers' characteristics. Good. Now, before we dive into the details, I want to give you the big picture up front, what we call the bottom line, through the following 3 points. First of all, our objective was to classify restaurant ratings into 3 categories: low, medium, and high, using a combination of information related to user demographics, restaurant features, and contextual data. Next, based on the most robust model of decision tree, we conducted a tuned random forest. This model outperformed traditional linear approaches like logistic regression, combining good predictive performance, lower overfitting, greater stability, and a stronger analytical coherence. This brings us to our key insight, that the relationship between customer satisfaction and restaurant ratings is not a simple linear phenomenon. Indeed, what truly drives a high score is the direct dining experience, which takes into account both food and service quality. On the other hand, factors such as geography, budget, or perceived value matter far less than we might assume. Well, with that in mind, let's talk about our development stages.
Hi, my name is Carlos. Let's take a look on the methodologies we use to transform raw data into predictive power. We did it following 3 steps. 1. Quality assessment. 2. Imputation and encoding. And 3. Trend test split. Our dataset showed heavy missiness in some variables, as zip code at 44%, parking at 48%, and alcohol at 65%. Zip code was one of the columns we dropped, since we decided it wouldn't be useful to our analysis. The other categorical variables was imputed with mode or with a contextual default. For example, parking, where missing values were imputed as no parking. After that, the variables were encoded to numerical labels. After dealing with the missing values, we applied a 20/80 split. So we got 928 training observation and 233 testing, yielding 23 predictive features. With clean data, we now were able to run our models. After splitting the data into training and testing subsets, the next stage involved the training and evaluating multiple classification models to predict overall rating. In order to establish a reference point for performance comparison, logistic regression was adopted as the baseline model. Since the target variable in this study is ordinal, an ordered logistic regression model was also included to examine whether an ordinal specification would provide a better fit. In addition, two tree-based models, random forest and XGBoost, were trained to compare their predictive performance against the logistic approaches. Here we have the results. We have logistical regression with accuracy of 39%. It means that it failed to capture complexity. It just over-predicted only the highest class. The ordered logistic, we have an accuracy of 38%. It's not very different. It's decreased the accuracy and even accounting for the ordinal nature of ratings provided no advantage. We have XGBoost with an accuracy of 70%. It handled non-linear patterns highly effectively, and a random forest with accuracy of 74%. And we have here a takeaway. The relationship between customer predictors and restaurant ratings is highly complex, so linear assumptions are insufficient for hospitality analytics.
Okay, now that we're going to talking about after the baselines and all the tests that we did, we can evidence that the core experience dominance algorithms get two variables that are really strong in our model. That is the food rating and the service rating. So we can see in this table how is that affect, what is the difference from these two variables that are really strong to the cuisine. Okay, now for the next part, so what happened is that we trying always to find the best model and how we can improve it, not just testing a model and that's it, that's our result. No, we always thinking more to improve or things that we can get better. Now what happened, it was the problem of overfitting. So what we're trying to do is the original random forest is trying to memorize, not to learn. So what we can see is that the accuracy was 99% 75 and the test accuracy is 74%. Now, what happened here is just we trying to fix the constraint parameters was trying to get the results as the result generalized. So what happened is once we trying to make sure we have that overfitting with the variables that we get. Now we get a better with the gap reuse that is from the 25% to 11, that is too much better, and the test accuracy is a little bit less, but is a good result. Now how we did this, so what happened here is that we did the evaluation with five-fold crowd valuation, highly mean accuracy of 69% 76 across all data participation. So this is something that is going to tell us that we are going in a good way. What happened now is that as I say, we always trying to improve and find different things. The option that we get is trying to create a new features that is help us to improve our model. So what happened here, we're trying to experiment to create the cuisine match, budget match, and distance kilometers using the longitude and latitude that we get from our original data. So we create these two variables and we trying to do the same thing, trying to test, trying to see the model, how it's learned, and we get different results. We try and we was thinking that we are going to get better results. But look, what happened here is that we have a random forest decrease from 74% to 61 and 70% to 60. So what that means that we still have like really powerful variables that we already have in our data set that is going to tell us, look, this is our variables that is going to help us more to predict more than the other ones, even that we are trying to create new features with the data we already have. So that's the thing that we have here. So a strain saying that is the word preference alignment and spatial proximity matters conceptually. their analytical uses, and in as fundamental through actual food and service quality are hidden. So that means that when we had these two variables, the model decreased too much, and we depend of these two models that are really important in our model.
So for our primary decision driver, we selected the tuned random forest because it achieved the optimal balance between predictive performance and generalization on unseen data. The architecture is an ensemble tree-based model, which we found was the only way to accurately map the complex nonlinear relationship that defines restaurant ratings. And to move the model from a state of high variance to one of stability, we constrained the hyperparameters, specifically limiting the tree depth and leaf size. And this adjustment reduces our performance gap from 25% down to much more reliable 11%. And we validated this selection through five-fold cross validation, which confirmed a stable mean accuracy of approximately 70% across different data partitions. So, in conclusion, our analysis translates complex data into three strategic pillars. The first one, the power of nonlinearity. We have proven that customer satisfaction is not a simple checklist. Management must evaluate the holistic dining environment as linear survey methods often miss those bigger things and that big picture of how different variables interact. Second, we found an unshakable core in the hospitality industry. Our experiments showed that even perfect proximity or budget matching cannot save a restaurant if the fundamentals of food and service quality are weak. And well, finally, this study demonstrates the immersive value of predictive analytics. This approach not only supports um, individual businesses, or but also enhances the overall attractiveness and competitiveness of the regional tourism sector. That's all for now, and thank you so much for watching.